In today's class, I'll discuss about functions. First, I will introduce function. What is function? What are the basic terminology? Definition: a mapping F from A to B is said to be function if each element of A has unique image in B. So here, what is the importance of each element and unique image? So here A is called technically domain, B is codomain. So here, which mappings are functions, which mappings are not functions. So it is F, here A, B are inputs. So here I am taking some elements in set A. So what are AB means? AB are non-empty sets. So here if I write 4, 5, 6, 7, this element has an image 4. 4 here is image of what? 1. 2 has image 5. 3 has image 6. So each element 1, 2, 3 all are having image. That image also 1 is having only one image 4. So this mapping is function. So another example, mapping which is not a function. Here F, A, B. If I take some elements, if I map 1 to 2 different elements of B, what it says, element 1 has 2 images. So, but definition, it must have unique image. Here you have 2 images. So F map from A to B is not a function because it is not satisfying definition. Every element must have unique image, but here one has 2 images. So another example, this example tells you about uniqueness. This example, which I'm going to give, discuss importance of each. If I say, for example, if I consider three elements in set A, four elements in set B, this is a one kind of mapping. But here, every element must have image. 3 has no image. So therefore, F map from A to B is not a function. So I think you understood the importance of each and unique. So why they put such a restrictions? Let us observe. This F is a kind of activity. So let us consider the same sets what I considered here. Activity means I'm taking this function as business. So here is input. This is an investment. B here either profit or loss. Let us assume profit. Once anybody invests, say, let us say, input whatever is there in A lakhs, it is in terms of it is in terms of thousands. Can he get anybody, whoever invests, two different of type of profits he will not get. Either 4,000 he will get or 5,000, both are not possible. That technically they restricted like that. Considering general thing in the nature. Here, this also same thing like that. Here, consider this. Same example. In the general sense, why that business here also same thing. Business. Here, three people invested amount. One fellow invested 1 lakh. Other fellow invested 2 lakhs. Other fellow invested 3 lakhs. Fellow who invested 1 lakh, he is receiving profit 4,000. Invested 2 lakhs, he is receiving a profit 5,000. Fellow invested 3 lakhs. In this example, he is not receiving any profit. Everybody must get profit. One fellow is not getting profit. Obviously, the differences will arise. Finally, it will collapse. That business cannot function. So, keeping general things in mind, so they define the function for us. Now, how to representation of a function. Here, this is how mapping is defined. How to represent this function means flower bracket. Element 1 has an image 3. So this 1 comma 3, we call it as ordered pair. Another element 2 comma 4. This is how we represent a function. In this representation, suppose you give a function like this, what this domain means, set of first elements of a ordered pair. First elements of ordered pair. Here, codomain means all elements of set B. Here you have another definition called range. Related elements. Related element in the sense here range is 3 comma 4. Codomain is 3, 4, 5. All the elements. Range means only related elements. Domain means, right, first elements of ordered pairs. Right. This range also has a notation f of a, means all images of domain A. Till now I discussed what is function, what is domain, what is codomain, what is range, how domain and how codomain and range differs means I can write relation between codomain and range as f of a. This relation, this notation, it's for is a subset of. Here there is a there are two different words. Is a proper subset. Suppose if I take 1 comma 2 is a proper subset of 1 to 3. So number of elements must be strictly less than number of elements. 1 to 3 if I take is a subset of 1 to 3. So right? So proper means strictly lesser elements must be there. Subset means maybe lesser or equal. Here is an example where range is a proper subset of codomain. If you take another example, F map from A to B, 1, 2, 3, 4, 5, 6. Here, in this example, range is 4, 5, 6. Codomain is also 4, 5, 6. So here range is nothing but B, which is f of A. Range and codomain both are same. So range can be either proper subset or can be equal to codomain. And once after defining function, any new system, how to add, how to subtract, how to multiply, how to divide, this plays a role. Operation on functions. Here, how addition is defined. Two functions, if we consider how to add, it is f plus g of x, which is f of x plus g of x. So for all x, this symbol is for all, belongs to it. This one belongs to. So let us consider two functions. One function f is defined like this. Another function here, how addition of functions is defined. Here is an element x. Here we have f image fx. So fx, you are adding functions, means you are adding y values. Here 1, 2, 1, 4, for example. Adding functions mean you should not add x values. You should add corresponding function values. 2 plus 4, that is 6. We are not changing x to 3 plus 6, means f plus g in the sense f plus g of x, fx plus g of x. For x equal to 1, f plus g will be f of 1 plus g of 1. Here f of 1 is 2, g of 1 is 4, 6. For x equal to 2, f plus g is f of 2 plus g of 2. 3 plus 6, 9. So x is not changing. Only for x, f plus g finally, for x is 1, f plus g value 2, 9. So like that, even f minus g is also, you should not change x, you should change only functional values. 2, 3 minus 6. This is how subtraction is defined. multiplication. This is what? Subtraction. Next one is multiplication. How it is defined means fg of x is it's a gameplay over only y values, not on x values. Let us consider the same example. One is as it is 2 into 4, 8. 2 as it is 3 into 6, 18. This is how multiplication is defined. Next, we have division. How division is defined? Notation is this: f of x by g of x for all x belongs to A, where g of x should not be 0. Once denominator 0, it is not defined. Let us consider same example. How f is defined here for us? F is defined as 1 comma 2, again 2 comma 3. These are two different. Here ordered pair is one element. G is defined as 1 4, 2 comma 6. F by G means it is again one side where first element will not change. 2 by 4, it is one element of F by G. 2, 3 by 6. 1 comma half, 2 comma half. This is how multiplication is defined, division is defined. Next, f power n of x, how it is defined means f of x whole power n, all x belongs to A. For example, if I take f as 1 comma 2, 2 comma 4, what is f square means? F of x whole square. This is x, it is fx. So meaning of it, first element there is no change, 1 4. To here is 4, it becomes 60. So this is how f square or f you can calculate. Next operation, kf of x, which is k times f of x. Suppose it's nothing but multiplication of function by scalar quantity. Suppose their f is defined as 1 2, 2 comma 5. What is 3f? 3f means 3f of x, which is 3 times f of x. For example, x is 1, 3f means 3f of 1, where f of 1 is 2. 3 times 2, 6. Don't multiply first element. You are only multiplying function value. Right. This is how multiplication of function by scalar is defined. Next, how addition of a scalar to the function is defined. F plus k of x is fx plus k. Suppose f is defined as 1, 2, 3, 4. F plus 1 means f plus 1 of x. F of x plus 1. So here, how do you write f plus 1? Here it is, x will not change as I have been discussing all the examples. It is for x equal to 1, f of 1 plus 1. So f of 1 here is 2 plus 1, 3. Simply adding that k value to the function 4 plus 1. 1, 3, 3, 5. This is how addition of constant to the function is defined. So next, so another question is it necessary that A and B must have same number of elements? Suppose here 1, 2, 3, 4, 3, 4, 8. Another set. This is not set, it is a function. It is f 1, 1, 3, 2. I'm defining. Now, how to add functions? Is it possible or not is the question. Possible. But how they define addition of function means same. But here it is defined on the set. Set means domain, one first elements. Another function is defined on the set 1, 3. So whenever their domains are different, all the operations are defined on the intersection. Intersection means common elements. Even 4 extra is there, we can neglect it. Right. Here, suppose you want to add two functions. It is restricted to only 2 plus 1, 3, 4 plus 2. We can eliminate this particular element. Or you want to multiply 1, 2, 3, 8. This is how multiplication is defined. So whenever their domains are different, the operations is applied on intersection. Next here, equal and unequal functions. So when do you say two functions are equal? When do you say two functions are not equal? Two functions f and g are said to be equal if they have same domain and their functional values are equal for all x belongs to. What I mean to say, which are equal, which are not, which are unequal functions. Suppose if I define fx as this, r means real numbers. G here is g of x is x square. Now, how f is defined? When x is 1, 1 square. When x is 2, 2 square. Here, when x is 1, 2 square, look at this. Function, both f and g are defined in the same way, still they are not equal because their domains are different. They defined in the same manner, but they are not equal. Here one element is additional. So minimum first condition is they must have same domain. So that is that since they are not having same domain, they are not equal functions. So another example, if I take fx as x, g of x as x square by x, both are seems to be same. F if I take 0, 1, 2, g also if I take 0, 1, 2, they have same domain. But here for input 0, f of 0 is 0, f of 1 is 1, f of 2 is 2 according to the definition. Here g of 0, it's not defined. So g here is, in fact, if this 0 is there, we cannot write g. If 0 is not there, or I can say 1, 1, 2, 2. This part is common, even though the domain, the input set you have taken same. It's not 0 is not in the domain. Input set you have taken same. Since it is not defined for 0, they cannot be equal functions. So here we are saying domain means for that domain values function must be defined. This is this example, it is not defined for input. We can't compare the functions. So when another example, log x square, g of x as 2 log x. Somebody may have logarithms in lower classes, somebody may not have. Log exponent property is n log x. According to that, log x square, 2 log x must be same. But whether the same or not, it depends upon the domain. F here R2 R minus 0 to R. because logarithm is a function is defined only for positive values of x. So if I take f of x as log x, f of minus 1, I say that f is not defined for negative values of x. Why in detail I'll discuss in the next class. Even though based on this formula, they are same. First function f is defined for f of minus 1 is log 1 has a value 0. But g of 1 minus 1 if you take is not defined. Even though they defined in the same manner, still f of x and g of x are not equal. Finally, how equal functions are there? Suppose if I take fx as x, f map from 1 to r, g of x as no problem in a different manner I am defining, but same domain if you take input where function is defined. In this case, when x is 1, here also when x is 1, 1, when x is 2. That means they should be defined same and their domains must be same. Then only we say f and g are equal functions.